Pascal's Triangle is the topic of the day. We are going to look at how to use Pascal's Triangle to multiply out powers of binomials. So let's look first at what Pascal's Triangle is and what it looks like. It starts with a 1 at the top. We call this the 0th row. It represents a plus b to the 0 power, which equals just 1. The first row is 1 and 1, which is a plus b to the first, which is just a plus b. Now here's how we get the rest of the rows, and you need to be able to build the triangle. I have 1, okay, because I'm adding this to what's outside, which is nothing. And then in the middle, I'm going to add 1 plus 1, so I get 2. And then I have 1 again because I have nothing to add to the outside. Then my next row, again, starts with a 1. All the rows start with a 1. I'm going to add the 1 plus 2, so I get 3. Then I add the 2 plus 1, I get another 3. And then I have 1 on the end. Okay, these are the second row, which represent a plus b squared. The third row, and these are going to be the coefficients, a plus b cubed. And then the fourth row is 1, and then 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4 again, and then my 1 on the end. So that's my fourth row. The coefficients for a plus b to the 4th power. And then I have 1. 1 plus 4 is 5. And notice like the first number in each row is the power that we're looking at. Then I have 4 plus 6 is 10. I have 6 plus 4 is 10 again. 4 plus 1 is 5. And then a 1. That's my 5th row. And we can keep going on forever. We get 1. 1 plus 6, 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. And 10 plus 5 is 15. 5 plus 1 is 6. And then 1. So that's my 6th row. And the nice thing about this is it allows us to evaluate, oops, I put a 7 there, or expand these polynomials without doing all of the crazy multiplication. So, for example, let's say I wanted to do x plus, or a plus b cubed, without having to do a plus b times a plus b times a plus b. So I'm going to start by looking at my coefficients, 1, 3, 3, and 1. Okay, now my a is going to start with a cubed. So in the first one, I have a cubed, and then it decreases power in each row, in each term. If you think about polynomials, we write from the highest exponent to the lowest, and when we multiply it out, it's a cubed, a squared, a, and then no a. They're the constant. So I have a squared, and the next one is a, and then the one on the end doesn't have an a. And then the b is going to go the opposite direction. I'm going to start b cubed, and then b squared, and b, and then there's no b. And because it's positive, it's all plus. So a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, so our next example is going to be a plus b to the 4th power. So 4th power is the 4th row, the row that has the 4 in it. So I write down my coefficients, 1, 4, 6, 4, and 1. I'm going to start with the a. In this case, since it's a to the 4th power, it starts with a to the 4th, and then it decreases a cubed, a squared, a, and a to the 0, which was just 1. And then on the way back, it starts with b to the 4th, b cubed, b squared, b, and no b, because b to the 0 was 1. So my polynomial, because it's plus in the middle, is a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. Now, what happens if it's negative? What happens if it's not just a and b? So we're going to look at another one, and we're going to look at the fifth power. So I want you to look at 1, 5, 10, 10, 5, 1. We're going to use this row for their next example, but I need to go to the next slide. Actually, I'll just move it up. Okay, this did not work the way I wanted it to. There we go. So this is 2y minus 4 to the fifth power. Okay, so we're going to start with our coefficients. 1, 5, 10, 10, 5, and 1. Okay, now instead of it being a, we have 2y. So we're going to start with 2y to the fifth and 2y to the fourth, 2y cubed, 2y squared, 2y, and 2y to the 0, which is 1. And then on the way back, I'm just going to keep account for my negative in the term. So on the way back, we're going to start with negative 4 to the fifth, negative 4 to the fourth, negative 4 cubed, negative 4 squared, negative 4, and negative 4 to the 0. So now we have to evaluate these. 2y to the fifth is 2 to the fifth. 2 to the fifth is 32. So that's 32y to the fifth. Then we have 2y to the fourth, which is 16y to the fourth, times negative 4 times a 5. Well, 5 times 16 is 80, and so 80 times negative 4 is negative 320y to the fourth. So we're just multiplying this all out. 5 times 16 is 80, times negative 4 is negative 320. And then I have 2y cubed, which becomes 8y cubed, because I'm cubing the 2. Actually, my parentheses is in the wrong spot on this one. I need to actually make the parentheses. I'm going to put them in green so we see the difference. This is 2y and then to the cube power. And so that's times 10 times negative 4, which again is 80 times negative 4, which is negative. I feel like these need to be down further. Hold on. I feel like it's too close. Hold on. Let me just rewrite that. We have 32y to the fifth minus 320y to the fourth. And then here's your 80 times negative 4 again. But I'm sorry, 80 times 16. Negative 4 squared is 16, positive 16. And 80 times 16 is 1,280y cubed. Okay, and that becomes positive because the negative 4 got squared. And then we have 2y squared, so that becomes 4y squared. Sorry, I put my parentheses in the wrong spots. And then that's times 10 times negative 4 cubed is negative 64. So that's 40 times negative 64, which is minus 2,560y squared. And then we have 5 times 2y, which is 10y. And negative 4 to the fourth is times 256. So that also is 2,560y. And negative 4 to the fifth is negative 1,024. So minus 1,024. So notice that my negative signs alternate because I have the minus in here. So then we're just multiplying this out. This is still less work than doing 2y minus 4 times 2y minus 4 times 2y minus 4. Doing that 5 times. Okay, I'm going to do one more. Let's do, let's see, 3y minus 7, let's just do cubed. Okay, same idea. My coefficients are 1, 3, 3, 1. And I get 3y cubed, 3y squared, and 3y. And then I start with negative 7 cubed, negative 7 squared, negative 7, and then no negative 7. So then 3 cubed is 27. So 27y cubed. That's 3 times 3 squared is 9. So 9y squared times negative 7. So that's 27 times negative 7. I'm going to break out a calculator here. 27 times 7. So that's negative 189y squared. And then I have 3y times 3 times 3y, which is 9y times positive 49. Negative 7 squared is a positive. So 49 times 9 is 441 y. The y doesn't have an exponent on it. And then negative 7 cubed is negative 343. Okay, and that's my final answer.